Okay, so NumPy. NumPy, what is NumPy? NumPy is a powerful Python library, which is a short form for numerical Python. Right? So you have numerical Python, which is a you basically it's a base level library, fundamental library. So which deals with it makes our job working with data really easy, right? As you will see. Right? It provides an efficient and easy way to store and operate on dense data. Although NumPy arrays look very much like Python list, they provide much more efficient storage and data operations as the arrays grow larger in size. Right? The NumPy arrays are at the core of almost all data science tools in Python. So NumPy next it's it's the fundamental base base okay. So if you can master NumPy, okay, so any data science things, right, the data science related stuff that you do, right? So okay, so you will get a very good your base training. My base एकदमै राम्रो हुन्छ कि यदि तपाईँले NumPy-लाई master गर्नु सक्नुहुन्छ। if you plan to do of course if you will use Python, right? Python for your data science tasks, right? Data analysis, data science task. Right? So mastering NumPy is a must. NumPy mastering on a person because it's so all library or your mathematical. So it's the pandas, which is another powerful library. Matplotlib, right? Even Spacey or all those things. TensorFlow, everything. Right? So they're basically based on NumPy. Right? So NumPy नै नभए पनि जुन NumPy हुन्छ very very similar to NumPy. Right? So NumPy ABCD जस्तै. Right? So that just like the alphabets, you need to know alphabets before you can read anything. Right? So this thing data science. Right? Okay, so so first thing you need to do is install NumPy on your system. Right? System and NumPy install. So with Colab, you already have NumPy installed. So it already comes pre-installed with NumPy. Right? So you don't have to worry. It's the Colab machine, the one where you're going to it's already there. You don't have to install. But it's like it's local system. You need to install like this. Pip install and NumPy. Right? Pip install NumPy. Pip manico Python package manager. Right? So if you don't have pip, you need to install pip. Right? Because pip install. So pip install भइसकेपछि then you can त्यसरी मेरो पहिल्यै छ. So that's why I get requirement already satisfied. Means I already have it. Right? So once you have it, what do? You go into the Python environment. And this is Python. Right? And this is you import NumPy. Right? Import NumPy as it. So all the way यति मात्रै गरे पनि हुन्छ. Right? Let me show you. It's the how. Now I want to know the version. Right? It's going to know version. Well, what version of NumPy do I have? Right? NumPy dot right? Underscore version. Right? Underscore version. You got everything. See, this is 1.19.4 version. Okay. And then but it's not so actually NumPy is very new use going to and if you see it's not feasible to use NumPy. Feasible to use NumPy type of 900 right? So that's why you can use some kind of an alias, right? Which is called an alias. So alias user so it will make our typing a lot less, and then your code is also less cluttered, right? So this client gives import NumPy as NP or something. This is standard. Although you can use anything, right? But NP is standard. So use this standard. Right? Okay, so we can do NP dot and underscore version, right? And then see, right? Okay. All right. So now let's see. Okay, so NumPy array. NumPy array is the basis of everything. that we do in Python data science. Hey, okay, NumPy arrays provide efficient storage as well as efficient operations on data. As opposed to Python list, we can store items of different data types. NumPy arrays can store only one type of items, meaning that all items in the array need to be of the same type. Right? So okay, so तपाईँहरूले arrays गर्नुभएको छैन in other programming languages, right? तपाईँहरूले गर्नुभएको छ है. So त्यसमा as you so त्यो र लिस्टमा के फरक पाउनु? What difference did you find between those arrays in other programming languages, for example, C++, Java?
List heterogeneous हुन्छ अनि array चाहिँ homogeneous हुन्छ.
Okay, yeah, that makes sense. Yeah. Okay, so yeah, that's right. Heterogeneous means, of course, you can put in anything that you want, any data type. You might go elements and items. It can be any type, any type, any data type. Whereas arrays it has to be one type. Right? So why is there that constraint? Constraint kina sata. You say arrays now. We need to have the same data type. Why do we have that constraint? Okay, I'll show you. Same mode, right? Okay, you want something very cool. Well, list is, of course, flexible. I mean, it's very, it's very convenient, flexible. That comes with a price, right? As you'll see. Right? Let's say the microcustoms there. So you list server, right? So we have this list, right? You list right? So for example, so I have one here, right? Rather use pen, right? Yeah, one is my hello sir. Right? And this was 3.14. Right? Okay, and then I have here say true. However, given some ID now, if I have to access any item, like any item, so how do I access the ID? You have your इसको हामी हरेक जुन एलिमेन्ट छ हरेक आइटम छ सबैको मेमोरी एड्रेस हामी स्टोर गर्दैनौँ हैन ओन्ली एउटा मात्रै हामीले के गर्छौँ भने एउटा मात्रै फर्स्ट जुन छ नि त्यहाँबाट त्यो स्टार्ट हुन्छ यो डेटा स्ट्रक्चर हैन त्यसको मेमोरी एड्रेस है त्यसको मेमोरी एड्रेस त्यो मात्रै राखिरहेको हुन्छ नि त हामीले है अनि बाँकी चाहिँ हामी कम्प्युट गर्ने है मेमोरी एड्रेस राखिरहेको हुन्छ हैन so if I want to get this, for example 3.1 per second हैन भनेपछि मैले के गर्नुपर्छ भन्दाखेरि now I need to know about you each भित्र के छ first I need to know what's in there say यहाँनेर के छ okay oh okay यसमा int रहेछ है so यहाँनेर के रहेछ oh okay so string str रहेछ यहाँ चाहिँ के रहेछ oh okay float रहेछ है and यहाँनेर के रहेछ oh bool रहेछ है so I need to know first thing I need to find out हैन what type of data there is right inside each of those your cells right? So first thing I need to know this right now I need to know how much the space they take up say int let's for the sake of this discussion so int leo right? This str of course depends on how long the string is right? So let's say 10 leo right float okay say so I'm talking about in terms of bytes. Bytes, you're seeing like 16 bytes. Okay, okay. And then let's see this just for the sake of it, 1 byte. Okay? Just arbitrary numbers. These are just arbitrary numbers. See, it's a bytes. Whenever see of mere calculation cost. So for example, let's go here. I know. I'm like yeah. Right? I want to access true. Like you access right? So then what do I need to do? Maybe first okay, their memory address. So let's say my memory address is say 90, right? It's a 90, right? In binary. Of course it's in binary, but let's do the calculation in terms of decimal, right? Decimal. So 9 छ है भनेपछि हाम्रो के भयो भन्दाखेरि अब यसको एड्रेस के हुन्छ नाउ आई निड टु नो यहाँ भित्र के छ यहाँ 1 छ यसको टाइप के हो इन्टले कति खान्छ 8 खान्छ आई निड टु सो यो सबै आई हेभ टु चेक एभ्री टाइम एभ्री एलिमेन्ट है मैले त्यो चेक गर्नुपर्छ है हामीले के उले चेक गर्नुपर्छ के अनि त्यहाँ भित्र के छ हैन के टाइप हो त्यो एन्ड हाउ मच मेमोरी स्पेस डज इट टेक अप हैन भनेपछि के भयो 9 plus 8 right okay is equal to 17 and you say 17 फेरि now it has to go here है अब यहाँ गएर है now it has to look inside what's in there right and then what type it is and then how much space it takes up so अब यसको चाहिँ कति भयो 17 plus this is 10 right equal to 27 right okay and then now I need to go 1 right 70 so I mean I'm true sum of numbers right true sum of numbers अब यसको मिसको मेमोरी एड्रेस कति है 27 plus I mean 3.1 छ त्यो float हो float को 16 छ है 16 is equal to and then whatever that is right 3 is that 43 okay so is it see so there's so much computational to expense गयो के then है तपाईको हैन so first you need to check what's in there right and then you need to figure out okay what type it is and then how much memory space it takes and then you need to do the calculation as well you see it's a really painfully slow process right painfully slow process right यो कुरा बुझ्नु भयो है okay so let's see अब यही कुरा if we have same data type है same data type छ भने अब कति सजिलो हुन्छ है सबैको सेम data type छ भने कति सजिलो हुन्छ है let's see so I'm going to take a snip of it so just in case if I need it and then okay? So I'll just take a snip and then I'll clear it out and then I just took the snip okay and then I'll more clear through okay I'll contrast this with this one and so we have this array where all the elements are the same type let's say 2 minus 5 3 minus 6 9 yes sir now look at this if I go memory beginning main memory access m right m now it's a competition so I want to for example I want to access say 9 right you access what do you do right all you need to do is 0 1 2 3 4 right so if I need to access 9 this one means all I need to do is what you see the memory calculator like each link right so it's the int these are all ints right int lay 8 bytes right 8 byte integer right 8 byte integer okay now what do you need to do right all you need to do is m plus right ani index kati cha index 4 cha right 4 times 8 that's it okay oh see यसको कति भयो हैन भन्दाखेरि यो चाहिँ यसमा +8 हैन +8 हैन अनि +16 हैन सो हेर्नुस् +8 किन भने अब यो चाहियो जस्तै यो 0 चाहियो भने 0 times the size हैन 0 times okay 0 times size चाहिँ 8 छ भनेपछि offset यो चाहिँ offset हो नि त हैन so this is offset अब offset कति सजिलो छ हैन offset क्याल्कुलेट गर्नुलाई भनेपछि जस्तै जुनसुकै जस्तै मलाई 1 millionth को जस्तै 10,466 index भएको छ and all I need to do is 10,466 times the space taken up by one element that's it यो कुरा बुझ्नु भयो तपाईहरु जस्तै ल तपाईहरु आफै भन्नुस् त भैया यसको offset कति हुन्छ इसको offset index 2 छ हैन 2 भनेपछि के भयो 2 times 8 16 16 offset 16 छ हेर्नुस् त यहाँ 8 भयो यहाँदेखि यहाँ 8 छ भने 16 भएन त है 3 को मेमोरी एड्रेस भनेको यो यहाँको मेमोरी एड्रेस हुन्छ है कुरा बुझिराख्नु भएको छ यो
Yes, yes.
So you have to, of course, you have studied in C, maybe just C. So and it's the calculation it's blazingly fast. It's a lightning speed. See, all you need to do is the starting memory address, right? And then index times the size of one. Size of one this cell. That's all. Right? So when you say, of course, so you can visualize you say you contrast this with this one. Right? You got the complex lines. Think about how the computer actually performs these. That's a corrective cycle to then you're expending a lot of cycles. Right? The CPU cycles, you're expending a lot of them. And then so small arrays like Hasif for that, maybe even 1,000, 10,000 arrays like that. When it comes to like millions, right? Then you see the performance gains there, right? So something arrays like Hasif for the NASCAR processor very, very extremely fast. The something arrays like Hasif, we don't see that performance gains. But when it comes to that in data science, machine learning, we work with large data, right? Large, and then it's all made arrays. It's all arrays, right? And then very high dimensional, right? High dimensional arrays, very huge arrays, right? And list use okay. So that's not an option at all. Listing is not an option. Okay. So does it make sense? Maybe you explain that. It's correct. Meaning, you intuitively, did you understand the difference?
Sir, offset total memory capacity.
Memory capacity your beginning the beginning the say your offset your beginning the beginning the it's an offset. Okay. So that's okay. All right. So okay, take some. Okay. All right. So
you into defense and the plot of Haragon, sir. You the into bio the string
okay. So or must say my string by many string a maximum and a maximum 80 you're saying you fix okay. Not that you efficiency again down there variable length variable length right. So say about floats of maybe a float to 16 means of anything formula right. Index times the size of each cell. This is 16 4 times 16 right. Okay. So when you see, as long as you know yota that's it. Right? Yota cell simple calculation simple, right? So beginning address, memory address plus index, zero base index it is zero base index competition very index -1 times minus operation 10 million arrays 10 million minus operation it all adds up. That's the reason we have zero base index zero base index arrays list zero start. It makes the computation easier. Right? Zero base index by 1, 2, 3, 4 Islam -1 index -1 and if the minus operation it's a huge computational cost because million is 10 million of big millions. So 10 million times you're subtracting, right? And then it all adds up, right? Okay. So because your competition cost right? Okay. All right, excellent. Okay. Let's go back to this. Okay. So now, how do we create arrays from Python? Okay, so basically, I'm the arrays are numpy arrays. And then, as you'll see, NumPy is very, very flexible, right? Very easy to use. Right there. So let's create some arrays. Right there. Let's create some arrays. So I've already imported NumPy. So so like when your array bound is simple, very simple. np.array, okay, and then you give a list. Say like 1, 2, 3, 4, whatever. It doesn't have. Say it could be minus, it could be 0, right? It could be anything, and as long as they are answers. Right? Okay. So let's see. Okay, so this is an array. You say array. Let's put it in a variable, right? So let's say our r is equal to that. If I do type r, see, it's a numpy dot nd array. Nd array is equal to nd means n-dimensional, means you can form any dimensional array. Like the three dimension array. So let's say call it nd array. Nd array means n-dimensional. Right? We'll see. Okay. All right. So okay, you saw that. Okay. So okay, let's see something. This is ISIMA. Right? If ISIMA if I put a say 4.99. Right? Let's see what happens. So if I do, of course, so what I can do is I can get the type. So each your return element, right? It's got type key of them. What is the type? So I can find out using dtype. Right? So let's see, r.dtype. So it gives you the float 64. Right? It's the only cookies. First, let's show you the first. So just say your case, right? This one. So say li r1 is equal to this. When you see the micro type the thing at the array. So dtype the data type. Right? Data type means the type of individual elements. Okay? So all you need to do is r1 dot dtype. Okay, r1 dot dtype.
Int.
Very good, because they're all ints, right? Int 64 something. Int 64. Right? So so that's understandable. Right? So how about this? I have r. Okay, with this see, something float by the understand. So actually, what I did was this. Understand? So all I did was let's see. Right? So yeah, it's only 4.9. Everything is here. So 11, 2, minus 3, 0, 8. They're all ints, integers, right? And yes, so I just introduced a float. Right? Yeah. So when I introduced a float, then what happened? Now r.dtype is now what? Float, you understand? And r type. So it's all converted or casted to float. Everything is a float now. Right? When it was offcast. Right? So offcasting, I think this happens in other languages. Right? This is offcasting. Offcasting means it always. So if there is another data type other than the normal, so this not the border, let's say more complex type, let's say offcasting. More complex, more complex. So of course, integer float is more complex, so it upcasted float, right? So this thing, if I can do another thing, and I'm saying, so what I can do is rather if I introduce say hi, I will say of a mere d-type say like let's see
str.
very good. Right? So r3 one, right? R3. So because out of data types, so what are they? Int, float, and then str. And you see which is the more complex, most complex means this string is the most complex type. Okay, so that's why, see, if I do R3 dot D type, okay, see, U32 means Unicode 32. Okay, you listen, maximum 32, 30 bits, right? 32 characters. Okay? 32 characters, U32, right? All right, so you say what's up by string, right? Unicode. Okay. All right, so this is called upcasting, right? So this is upcasting. Okay, let's see. So, but we can force, and the force going to say, I want to force this, say your Erson, right? So rather, I don't want that to be, right? Okay, so let's see. It's the Yanira, right? 4.9, sir. But I want the right? I don't want this to be float, right? I want this to be integer, means I can force. Positive force. That's not D type. I can actually, your argument, sir. You can D type is equal to, and then I can force it to be int proportional. Okay, let's see. So let's see, R3 dot D type. Right? See, I get int 64. Right? Okay. Otherwise, you're not here with you. Understand? You're not here with mere D type Q.
Float on sir.
Float 64, of course. But since I forced it, right? So you see, I can force it to a string as well. Right? String force on the so let's see. Okay. So R3, of course, right? Dot D type. Let's see. Photo. Right? So it's a U3I, right? 3 characters, maximum 3 characters. Right? Okay, so we have 10 minutes. So if you disconnected, once you disconnect, please come back. Right? Come back. See you. Okay, so here, okay. So let's see. What else? Okay, so we can create see multi-dimensional array. A multi-dimensional array. Let's say for 2-dimensional array. Right? Or I'm just going to create a 2-dimensional array. Right? So let's see. Let's call that R2D is equal to. Right? So let's quickly do that. So I'm going to create a very simple one. Right? That say minus 0, so and this C 1 comma 98 comma say minus 56, whatever. Right? So if I do this, oops, sorry, I meant minus. So okay, so this is R2D. So R2D, let me show you this. Right? So R2D, right? Look at this, right? So U is minus. Huh? So now this is supposed to be 2-dimensional. Right? This is 2-dimensional. Right? So let's see, how do we know it's 2-dimensional? 2-dimensional possible. Right? So this को लागि के छ भन्दाखेरि हामीलाई numpy array के method के attributes through which we know what यसको यो थाहा हुन्छ कति डिमेन्सन हो जस्तै त्यसमा चाहिँ एन्डिम भन्ने हुन्छ अनि साइज भन्ने हुन्छ which will do the same way. So I just want to show it like that. At least shape भन्ने हुन्छ. Okay? So okay, just say I'm going to use endim for now. Right? So मैले R2D dot endim गरेको endim भनेको number of dimensions. Right? कति आउँछ होला number of dimensions? 2 of course. See? Wait a minute.
numpy array नै बनाएको छु सर माथि.
Oh yeah, thank you. Yeah, thank you. Sorry, it's a numpy array. So no, and then now it should work. Right? So this is simply list of list, right? So air2d dot np. Very good. See, 2. Okay, 2 add. Okay, so so now if I print air2d, now it's going to look a little. It's an array. It's an array. Okay, you kati by kati array. Of course, you guys know.
2,3.
Yeah. Also normally called 2 by 3. 2 by
2 by
3.
3.
Not 2 by 3 of course, because there are 2 rows. There are 2 rows and 3 columns. 1, 2, 3. 3 columns. There are rows 1, 2, and then there are 3 columns. 1, 2, and 3. Okay, this is the like 2 by 3. 2 by 3. And this could say we can do air2d dot shape 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 your dimension. So this is one dimension, this is another dimension. First dimension second dimension 3. You see row first dimension and column second dimension. Okay, first dimension row second dimension column. Row always row comes first. Row comes first. Row comes first. Row comes first. Okay, so we just created a 2-dimensional array. This thing we can create any dimension array. Okay. All right, so creating arrays with built-in methods. There are some very convenient built-in methods given to us by NumPy built-in methods to use. We can conveniently and quickly we can create arrays. Let's say np.zeros. np.zeros. If I do say 6. And then you'll see that. So on the array here, just making 6 order. So 1, 2, 3, 4, 5, 6. It's order zeros. And this could D type key. This could D type key. And it's a D type key. What system? Right? The zeros is called D type 6, 464. So of course, because you see a point here, right? Decimal point that means, so that's why. I mean, yeah. So it gives that hint right. You can get the hint from individual feature. Okay. Okay. So now let's say zeros ornaments. So likewise, you can do np.ones, right? One spinning ornaments. So np.ones and ones column is simply ones calls. See. And same thing. So again, it's float, right? But it's all ones, right? Simply ones. Okay. All right. So very good. Okay, we can do. See, now we can create any dimension. Right? So let's say if I do np.ones, right? And my linear right? So my layer above 3 by 2, and 3 by 2. So my shape, okay, you see this. You got like kati by kati area
3 by 2. 3 row 2 column.
That's correct. That's correct. Right? So 3 by 2. I mean 3 by 2. That means 3 rows and there are 2 columns. Right? In rows, there are columns. Very good. Right? So likewise, I can create even say 3 or 4 dimension, 5 dimension, 100 dimension, any dimension. Okay, I can create a top design. Okay, so it's the top. Okay, let's see. Say about let's see. Let's put a smaller number. Too big of a number. Okay, so that's so air underscore. Okay, so if I do this, okay, so I would say like air underscore dot d type. D type of the is called ending for things, number of dimensions.
3.
Yeah, that's great. Great, because you see here, neighbor found. Okay, Any you dimension, you order dimension, yeah, theta dimensions, right? This is first dimension, second dimension, third dimension, right? Okay, so of course it's 3, right? Okay, so shape thing, shape thing. That's my yeni shape.
3, 2, 4.
As a triple, yeah, 3, 2, as a triple, right? Okay. Very good. So, so you can see that. So this is the So if I do this, rather, so you say the really too low, but it's still. So yeah, it's not too bad. It's not too bad. So yeah. So Isma, can you make sense of this? Your using the Q is let's try to find out the. Let's relate them, right? Theoretically relate them. Okay, so it's my keyboard. Let's think it's of course a 3-dimensional array, right? It's less than 1 minute. So I'll just stop here, and then click join back. Okay? Energy. Click join back again.